All right, guys, this is the chapter 9 review question. This one talked about the number of railroad cars and fuel consumption. So the first question said, is the linear model appropriate to use? The answer to that question is yes. So we always answer the question. The model is appropriate to use. And then we have two reasons why it's appropriate to use. The first one is the scatter plot shows strong positive linear association between the number of cars and fuel consumption. So a couple of things that I want to point out in that one sentence. One, I put context in there, and we always got to put context somewhere in our answer. It has to be in there somewhere, okay? So I didn't just say that the association was strong, positive, and linear. I said what the association was. I basically said, here are my two variables, okay? So that's one thing. It was, and the key thing there, it was positive. It was linear. Key thing is that it was a linear association. So that lets me know that my model is appropriate to use. But the most important thing there is that the residual plot has no form and has random scatter. And if you remember doing that right, we could come up with our residuals. Our calculator would find our residuals, and then we would do a scatter plot of the X variables versus the residuals. And what we were looking for there was nothing. We were looking for random scatter. And random scatter means that the linear model was appropriate to use. You don't want any type of patterns in your residual plot. So those are the two parts for A. Part B said, how much does it cost when you add a car, basically. So the first thing we need to state there is that fuel consumption increases by 2.1495 units for each added car. That is basically the definition of the slope, the interpretation of the slope, that the y is increased by the slope for every increase in 1x. You can go back and review those things, but that's interpreting the slope. But then it also tells us that the fuel cost is $25 per unit. So if we multiply those, and they need to see you multiplying those, you get $53.75. So that's how much it's going to cost for each additional rail car. Make sure you put the formula down. Make sure you write it all out. Okay, they want to see, where did you get the $53.75 from? Next thing, again, they ask about R squared. This is the second problem we've done where they've asked about R squared. So they said identify it. So it's the 96.7%. And then we need to define it or interpret it. Sorry about that. And the interpretation is the variation in X accounts for R squared percent in the variation of Y. So I put the context in there. The variation in number of rail cars accounts for 96.7% of the variation in fuel consumption. So that was the part C. And then finally, it says, hey, can we do this for 65 cars? If you go back and you look at the scatter plot, you'll notice that the largest number of rail cars that they used when they collected their data was about 50. I don't know if it was exactly 50, but it was 50. They're wanting us to plug in 65. So this is just textbook extrapolation here. So I'm answering the question, no, we should not use it. And then I said the data collected doesn't have any rail cars above 50. We would be extrapolating if we use 65. You can go back and look in chapter 9. There's a real great problem there that talks about years. And I think the average age of men when they got married. And as the years went on, it kept going down and down and down. Well, obviously that isn't going to continue, right? The average age for a man getting married isn't going to keep going down and down and down. If it does, then all of a sudden, Deacon, my 2-year-old, when my 2-year-old, he's going to get married, which obviously is not going to happen. That's your answer for part D. If you guys got any questions, please remind me, and I will see you in the next video.